starting again with lesson 6 of the Visual Functional Mathematics NT3 level for you. And today we're going to talk about angles and lines of symmetry. What are angles? What are lines of symmetry? Angles tell you the size of a corner. When two lines meet, they form an angle. When two straight lines meet, they form an angle. And that angle can be measured if you need to work with it for a particular purpose. Some shapes have a line of symmetry. Symmetry also is a very interesting concept because it occurs in nature and also it can be constructed in man-made structures. Some shapes have more than one line of symmetry and some objects don't have any line of symmetry whatsoever. So let's look a little bit more. Angles. They tell us the size of the corner, as I told you. And if you look on the screen there, that is an angle. And angles can be big or small. You got acute angles, you got obtuse angles, or they can be more consistent. You have square angles. You need to be able to recognize these things and identify them. Smaller angles are shaped with sharper points than bigger angles. Bigger angles are wide and angles are useful because they tell you the size of a corner. You have a right angle, which is a special type of angle. It looks like the shape on the right or the bottom right, and it's usually found in squared objects, what I would call the corner of a square. Now here are some practice questions. Remember, this lesson at NT3 is for you to be able to identify angles in a constructive way because you'll be working with them as you progress to level 1 and hopefully level 2 in your study of maths. So, which angle is bigger, A or B, on the object on the right? And then there are 3 shapes at the bottom there for you to look at and write down the number of right angles in the following shapes. Remember, some shapes can have more than one right angle. Now let's look at lines of symmetry. Symmetry simply means mirrored image. If you take a mirror, you look at it, what you see is your mirrored image. But then some shapes, although you're not using a mirror because it's the one shape, you can fold it in a way that makes it look, either side looks exactly the same. So some shapes have one line of symmetry and some have more than one line of symmetry, and some have none. Let's try to identify some of these shapes now. You can find out whether a shape has a line of symmetry by folding it in half. That's how you find out. If the sides fold exactly together, then the fold is a line of symmetry. And the line of symmetry can be vertical, as you see on the shape on the top, which folded vertically. And it can, in other shapes, it can be horizontal. But in this case, the 2 shapes you're seeing there, although they look different as a whole, both of them have vertical lines of symmetry. And let's look at some shapes which have more than one line of symmetry. The H you see there has more than one line of symmetry because you can fold it in half as in on the first fold. You see it's vertical, but when you fold it in one, you see one line of symmetry clearly, and then you can also fold it horizontally and still get another line of symmetry. So that shape has two lines of symmetry. And still yet, some shapes have no lines of symmetry at all, like the Z you see there. Try to fold it vertically, you will not get the same shape. Try to fold it horizontally and you'll get a completely different shape whatsoever. See if you can think of any other object that does not have a line of symmetry. And of course, objects that do have lines of symmetry. Here are some practice questions for you. Draw one line of symmetry on each of these shapes. You will have to draw them out yourself, as you cannot draw on the screen. Okay, as I can see now in A, I can see one line of symmetry in B, and then write down how many lines of symmetry each of these shapes have. So you have to look at it critically, possibly get a pen or a paper, cut out the shape, and try by folding it out. That is why this is called the visual functional maths. Sometimes you have to do things to find out what's happening and to find out the truth about them. Okay? Now, what have we learned so far? You can see that this is a very short lesson. We will be applying them later on as we progress with our learning of maths on Unit 1, at Level 1. You now know that angle tells us the size of a corner. You have big angles, you have small angles, you have right angles. They all have their names. See if you can find out, or you can remember the names I mentioned at the beginning of the lesson. Symmetry described mirrored shapes. Why? Because when you fold it, you see it forms an exact shape on both sides. So you can draw a straight line of symmetry vertically or horizontally. And some shapes have more than one line of symmetry. And some shapes are not symmetrical. What do we mean not symmetrical? That means it does not have any line of symmetry. Shapes with lines of symmetry are described as symmetrical. Now let's look at some photos of some natural objects and man-made objects that are symmetrical. So you see the natural objects, butterfly tends to be symmetrical. If you draw it out on a piece of paper, you can fold it in half vertically and you'll have the exact shape. Christmas tree, well, more or less, but the shape of a Christmas tree, the cone shape suggests that it can be symmetrical. So can some leaves, well, most leaves really, you see. And then of course you have the ladybird, which is quite amazing because even the spots on its wings, its outer wing, are symmetrical in the sense that you have exact number on either side, and then the one that is attached to its head is also symmetrical, right? So it forms a perfect vertical symmetry. At the bottom you see some very famous building. The one on the left is the Taj Mahal, one of probably the most beautiful building in the world, if you ask me, in terms of its art history. But look at how it's structured. Even the garden is designed symmetrically. This is man-made. And then you have the Pyramid of Gaza, which is very beautiful at night. It's now a very attractive tourist destination. But just imagine, considering those pyramids were made some 3,000 years ago. So you can see how similar ancient minds and modern minds can be. And then I believe what you're seeing there on the right is what they used to call the Twin Tower, or something similar, which also is like some twin building with exactly the same construction. But if you look at it from this bottom angle, you can see that it has a horizontal line of symmetry, which means that like you're looking it through a mirror. And I suspect that if it was possible to fold the photograph in half, you will also have a vertical line of symmetry on both of those structures. Okay, that's our lesson for today. Now go through the practice questions, try to get them right, and